And you get to go back. You know, it's funny. This class, I went to the last problem and started working backwards and through the homework. The second class, I started the top, go to down. So I guess what I'll do is find out where I am and complete them all. So this is homework one, and you can see all my chicken scratch here. I think this one I did in the afternoon. So I did this one, did that one. You can go look at the video. Okay, this one, I don't know why I put that in there. So I apologize to them for putting that in there because it was kind of one of I would never do that on an exam, but maybe I was just having one of those moments and I just put it in there. So it's there and it's a mess. And near the end, I just got tired and wrote down something. And I'm not even sure that this last part, but you know, use your best discretion there. This one I thought was a really good problem because this one had some sort of context to it that made sense. And so you think about it, an airplane lands on the runway, originally traveling 111 when S is equal to 0. If it's subject to the deceleration shown, and have you ever been on there? They do their little I forgot what it's called, reverse vector thrust, where it goes boom, and the engine has this little fan that pops out, and it just slows you down all of a sudden. So I'm guessing that's maybe, but you know, okay. So he has two regions of it where it's -3, and then another one where -8, and another one's -3. So if you look at this one, all you're trying to do is get that integral to be reduced by that. And so you start with that one, you end up with 40, and 30 and 40 doesn't equal to 110. So you got to make up the rest of the difference right here. And for some reason, oh, the screen is weird. I thought I cleaned it. It's like somebody ate on it or something. So I don't know what's the deal. I'll try to get some sort of screen cleaner for next. I don't know. So anyway, so I did that one, and we kind of figured out the delta time. I think, nope, that wasn't the last one. Okay, so then there's the motorcycle. Now, this one is a pretty good one from this standpoint, going from here to here, but taking a quadratic and forcing you to come up with a cubic, I would not do that because I just don't want to have to deal with that. Taking a linear and going that way, it'd probably be okay. Now, again, on the test, it's not going to be any of this. It's going to be, let me see where I'm at. It's going to be more along the lines of what, like, for example, what's the position at t is equal to 2 seconds? What is the acceleration at t is equal to 2? And there'll be a number here. So there's not going to be a plot. I don't want to grade any of those plots. Those things, they're hard enough to figure out because you got to figure whether they're concave up and concave down. And you can do that if it's quadratic pretty easily, but if it's cubic, it's kind of sometimes hard to figure out what the plot's doing. Unless you have MATLAB and you can turn on MATLAB and run it, you know, which I doubt. Let me see. I'm going to see. Let's take bets. He's going to take bets with me. How many people think it works? Yeah. Oh, no. At least it's very polite when it... I did that last time. And then it sends you to the MATLAB site that tells you you have a license error. So, yeah, it is. But I can't solve it. I don't have the license servers over there. As they update the license, they need to go around to each machine and update the license file. So we'll just keep going. Okay, this one. Okay, now this one's not a candidate for ending up in there. And I'll apologize right off, but this is a good one to see this here. Let me switch to, and that is, you start with this, and then you end up with, well, I don't have the velocity as a function of time. I have it as a function of position. which tells you have the velocity times dv ds equal to acceleration. And now what he's got, okay, and go one more step, v dv, the integral, is equal to a ds. Now this is awful, because now you've got to work your way through this. So I've got to take this one. There's no real way to look at it per se right off and see a slope. So what you've got to do is you've got to go in here and take the integral of this inside here. And then once you've got that, you got to figure out how you're going to work out the rest. Oh, I'm sorry. I misspoke. Let me fix my error of many ways. Okay, let me go back to here. Error. Now, okay. If I could rewind the video, it would rewind it right now and go back to this point. So, sorry. I thought that was the acceleration plot. Sorry. Never mind. Forget it. Forget what I said. Now, let's go on what you're supposed to really do. You're supposed to take 0.1 s plus 5. And then you're supposed to put this in. I guess if I do this here, I can just, I don't know what to do. I'll write it right here. dv ds is equal to just 0.1. So you just get 0.1. That's acceleration. So now it's up to you. I guess if you decide you wanted to, you could do that. And then you realize it's the same plot times the coefficient that sat there. So I don't know, like that. And then this one is going to be the same thing, except you're going to have, okay, so if you do that here, dv ds is equal to minus 0.04, which means the acceleration is equal to minus that plot. So if you have minus that, 0.04 times minus 0.04 s plus 19, what do you think that looks like? Yeah, I guess you really have two choices. You've got that one or this one. That wasn't supposed to do that way. That one or this one. Which one do you think it does? Yeah, well, now wait a minute. Let's think about what happened to this one first. Okay, so first of all, let me just check this. I've never worked this problem, so it's annoying me, so I may actually do more than I should. If that's 15, what value should that be? Oh, I'm sorry, acceleration versus s. So I'm looking at this. Yeah, now it's a function of position, because that's kind of what he asked there. Shouldn't that be 1.5? Because if it's 15, you're multiplying times that constant right there. Now what worries me, and it's an okay worry, acceleration over here should be 0.0016 s minus 0.04 times 19. I know what it's supposed to be. I don't know. Okay, let me check. 0.04 times 19, 0.76. Okay, now if I look at this thing, I put in S equal to, looks like 100, and the acceleration at 100 would equal to 0.016 minus 0.76. That doesn't seem right. So what happened there? So is this continuous or is it discontinuous? So did I do that correct? Okay, first one. Okay, I think I did this one correct. And let me put this in again. Oh, what? Wait a minute. Let me do this again. Okay, got that number times 100 because that's where it's supposed to be. Oops. What am I doing? You should have caught that. That is 0.16. Okay, 0.16 minus 0.76. It looks like, how do I make this go down? Okay. It looks like I go all the way down to here, and that value is minus 0.6. Now let's try to figure out what happened there logically. And let's make sure that, okay, then it looks like I decline. Now, let's see if that makes sense. So, as you look right here, okay, so did I do the math right first? Let's look at that part. And then we'll go and try to perceive what I did. I think that's the right derivative. And then if I'm multiplying the derivative times itself, I think that's the right term there. I think I copied that down correct. Put that in front of it. Figured it out. Got a minus 0.6. Okay. Oh. Since, oh, well, now the velocity changes, though. You're talking about position. Yeah, so it's, see, the interpretation here is a little bit different. Now we're in the wind tunnel. And so we look at this thing, and let's just be, I'm going to go back over to the other screen, and I'm going to try to figure out what actually happened here. So, well, maybe I don't want to necessarily mess this one up, but I may mess it up anyway, just for kicks. Here, I'll go in and do format options. No, wait a minute. Okay, wait a minute. Home. Insert. Nope. View. Anyway, here, let's go over and look at these. Let's do this back over on a sheet back here. So I have the thing coming up. This equation was 0.1s plus 5. Okay. 0.1s plus 5 came up to 100. Then it started going down. What was it? 0.04s plus 19. 0.04s plus 19. But it was minus, right? So if I sit right here and look back, let's say this is going to be a little bit strange. So let's say I'm looking at S is equal to 1 point, say, well, now not 1 point. Say, let's say it's 99. I look at S is equal to 100. And I guess I'll have to say S is equal to 98. So if I look at these three, what do I get? I get 1.5 here, right? Let me double check that. Ooh, I made a mistake there. Did I do that wrong? That's supposed to be 15. It's the fact that I'm so excited about my free lunch. Actually, I don't think it's free, actually. So it's 15. Let me go and figure out what this value is. Okay, so what is the next value? Next value right here is at 99. So 0.1 times 99 plus 15. What? Plus 5. That's 15. Okay, 99 times plus, okay, 14.9. And I'm guessing that this would be 14.8. So this is a delta of 1 and 1. So if you look at it like this, V is equal to, let's sort of take a look at it. Well, it looks to me like, actually, sorry, acceleration is equal to V times the change in V with respect to S. It looks to me like it changes at a value of 0.1 for every 1. So rise over run here. So it's the delta here is 0.1 over 1. So the delta is just 1. So then if you just say, well, it's 14.9, well, that's roughly acceleration at this point be 14.9. Did I do that right? No, 1.49. Man, I'm goofing this one way up. Are you ready? Do you get it? Sorry, I'm having too much fun with that. 1.49. So now, when you sit right here, this is the key. What happens over here? What's the acceleration right there? I'm sorry, what's the velocity right there? The velocity right there is, and I'm going to say this is at location 101, 1 times 0.04. So it's 19 minus 4.04, or around 14.96. So if you look at this spot and you look to your left and you see 14.9, you look to your right and you see 14.96, it almost appears like the acceleration is almost zero there. Then the next key is you look at one more spot out here at 102, and at 102 you see 19 minus 0.04 times 102, or 14.92. So what you're seeing is you're looking to your right, you're seeing he's going slower. You look to your left, he's going faster. So he's got to be decelerating some. So he has to be underneath the axis. So this time, if you look, and actually I should be able to slide to the right on this one. If you look at this, you know, acceleration is equal to V. The change in V with respect to S. Well, this time it's going down, and it's not too surprising that this slope, it's going down at a minus 0.04. You look at the velocity there, it's around 14.96, roughly right here. So it's decelerating. Oh, and I got 14.96 times 0.04, or about minus 0.59. So in fact, that does make sense. So if you're staring at it and you see him coming at you from the left, he was going faster to the left of you, slower to the right of you. So as he came by you, he's slowing down. So it has to be decelerating. So I think if I see myself, I think I've got that now. So I got 0.6, oops. And you know what? I think as you look at this, the acceleration here, I think now that I see this, I see a 0.76, but as S progresses to the right, it kind of goes like that. 350. Yeah. Oh, okay. Negative 0.2. Okay. So it takes a little bit different type of interpretation. Now, I'm not going to do this to you on the exam. I'm satisfied if you can do the other ones. But at the same time, this requires you to, and it's good for you to think this way and see this, because when you move into fluid mechanics and you're walking into the fluid lab, that's what you're seeing. You're staring at the wind tunnel and the wind's coming by you constantly. So you look to your left, and if it's going faster, and you look to your right and it's going slower, then you know he went from 100 miles an hour to 99 to 98. But you stare at that one spot, he looks like he's going the same speed. But as the particle came by, it was slowing down. And so it was decelerating. So this one takes a little bit of different look to it. So there you go. Are we okay with that one? I mean, sorry I flubbed up, but it's okay. Yeah, that's it. Yeah. Yeah, what I was doing here was trying to interpret it. So I was trying to interpret to see if what I did with the equations over there was right. Over here, I was just plugging them in. And then, of course, what I did is I goofed up the plot. And I did that really well. I mean, so the plot itself, I thought I just changed the color. The plot itself should be this, and then that. But it took me a minute to sort of gather my wits about me. But the way you can look at it is for the linear, okay, this is not always the case. If it's linear, you get one thing. If you get a quadratic, it might do something different. Because, and I don't think I did I do one of those? I probably shouldn't do one of those, but I better do the homework, get done with this first, and I can go back and address that maybe Monday or whatever. A particle is constrained to move along that. Determine the magnitude of the particle's acceleration when it's that time. Okay, well, how would you do this? Okay, first of all, how many more of these got to do? Oh, okay, well, I've got that one. That's an easy one. You could do that one. So let's spend a few minutes on this one. This one is quite annoying, but it's not bad. Okay, so first I'm going to gather this thing and this thing. So what I'll do is I'll just say this, 4t to the fourth. However, if I look at this is y is equal to square root of 4x. So me, being the person that doesn't want to work terribly hard, I would say y is equal to, 4 times 4t to the fourth and the square root of that. That's kind of convenient because I think it's 4t squared. Is that right? Did I do that right? Let me know if I didn't do it right. If I did, I'm just going to go on. And so he wants to know the particle's velocity and its acceleration. Well, all right. So if I want to know the velocity and it's in Cartesian coordinates, I just have this. That's supposed to be a J. And then I can take, I'm only interested in that, and I'm only interested in this. So I use this to get myself to x is equal to a function of time. I think it's what? What's 4 times 4? Is that 16? T to the third, I plus, what's that? 8t j. And you can do the other derivative, where acceleration is equal to x double dot I plus y double dot j. And that's pretty much it. So at first glance, oh, he had this down here. Okay. At first glance, it seems difficult. When I first saw it, I was initially thinking he was going to force me to find radius, but I don't have to. Oh, well then, okay, but I have to remember to put in, when I get done, I have to remember put in t is equal to half a second. If I'm going to look it up in the back of the book, that's what I have to do. So first glance, I thought it was harder than it was. So I guess we do have time to monkey around with this one. This one, you notice what he did? Oh, okay. Well, he went ahead and gave you your X, and he went in and gave you your Y. I don't see any particular reason not to use those, especially since that forces X naught to equal to Y naught equal to 0. That makes things easier. Determine the speed must be thrown at an angle of 30 degrees to make it into the basket. Now that's assuming that he shot it in the right direction. Because many times I've shot and I thought it would have gone right through, except it was a foot to the left.
This guy over here is like choking it straight in. I didn't say it was bounce off the backboard. It's not back in his teeth. There's not much on each other.
No, that's true.
Shooting like that will get your laps.
Oh, really? Did they make you run laps when you shot like that? Really? What if you would have made it? Did you have 2 laps then?
Well, then you still got your choking, but this is bad form.
Oh, okay. It's the basics. It's the basics.
That's one of those where they scream at you and touch you on the belly.
Oh, yeah, that's it.
Don't ever do that again.
Yeah. Well, that's like, what was it, Nick Saban, when they put in that last guy or something?
Oh, yeah.
And he was going to pull him out. He was like, well, I was getting ready to pull him out, and then he won the game.
Yeah.
Okay, so he's pretty good. So it's like, okay, sometimes when they're on the field, just the best thing to do is he's already done his work. He's recruited the right people. Just let him play. Okay, so X is equal to X naught plus V naught T, and then Y is equal to Y naught plus, okay, it said VX, should be VX naught, VY naught T minus GT squared over 2. Then you got this, clobbers those out. He was really wanting to find the speed, so he's wanting to find this and this. So I'll say X is equal to, and I'll go ahead and break it down. Let's see, VA cosine 30 T, Y is equal to VA sine 30 T. Did I do that right? Yeah, minus G T squared over 2. Now, it's in meters. So now I can sort of poke around at it. And if I'm looking at that, at point B, I get X is equal to 10, Y is equal to, looks like he came up that and came up, so I think it's another 1.5 meters. So there's 2 or 3 ways you can do it. One is you could just put in X right here and Y right here, but me, I keep going back to this, and I hate to keep doing this because there's other ways to do it. VA cosine 30, and then I'll take that, stick it right there, and take it, stick it right there. So Y is equal to, okay, X tangent 30 minus, and I might as well put in that one, 9.81 over 2, and then T squared would be X over VA cosine 30. This has to be squared. And then you just solve. Well, no, first you put in X is equal to 10 and Y is equal to 1.5. And then you solve for the V, and that's it. And then the others are done. That's kind of there. That's kind of there. That one's kind of there. It's all there. You should be able to. So, yeah. See how fast? There you go. And then I guess we'll do the same thing when we come to this. This is on 12, which we kind of got done with. So, uh-oh, there's my timer. So, and I don't want to repeat because then I won't get my lunch. I don't know. That's the happy song. There's food available. But you've got to pay out the nose. Okay. Well, I'm not really sure. I know everybody.